If we have a neutralization reaction, sulfuric acid with sodium hydroxide give us sodium sulfate and water, we have an amount of sulfuric acid and an amount of sodium hydroxide. Once we have an amount of both reactants, it's automatically a limiting reactant problem. And we have to figure out the product based on the limiting reactant. So we have to figure out the limiting reactant at the same time. So the easy way is to calculate the amount of product from both reactants. And then if we're answering just what is the limiting reactant, I'll show us a shortcut that we can use to just answer that question. So to figure out how much product, so we just have to use, we're just using one product, we have to use the same product for both calculations. So we do mass divided by molar mass to get moles. That gives us 0.347 moles of the sulfuric acid. For the sodium hydroxide, we take the 27 grams divided by its molar mass, 40 grams per mole. And we get 0.675 moles of sodium hydroxide. If this was a one-to-one reaction, we could compare the moles directly to figure out what is the limiting reactant. It's not one-to-one, so we can't do that. I'll show us a shortcut that we can do in a little bit. Otherwise, we take our moles of sulfuric acid, use the stoichiometric ratio, the ratio of what we want over what we're starting off with. This is the ratio of the coefficients from the balanced chemical equation. So for sulfuric acid, it's 1-to-1. That will give us moles of sodium sulfate. We multiply it by the molar mass of sodium sulfate, and we'll get the mass of sodium sulfate. We repeat the reaction, repeat the calculation with sodium hydroxide. The molar mass divided by molar mass gives us our moles. Multiplied by the stoichiometric ratio, now it's a 1-to-2 ratio. Multiplied by the molar mass of sodium sulfate. We get 47.9 grams. So we have an amount for both reactants. What we do is we pick the smaller amount. We're never going to use that larger amount at all. So the smaller amount is our theoretical yield. So that is how much grams of the sodium sulfate is made, or can be made. We'll talk in a different video about why we might not get this much amount. So this is a theoretical yield. And so we can see that even though we had more moles of sodium hydroxide, less moles of sulfuric acid, the sodium hydroxide becomes the limiting reactant. So the reaction that produces the smallest amount of product is our limiting reactant, so that's our sodium hydroxide. Now there's a shortcut that we can use also if we're just asking the question, what is the limiting reactant? So if we look at these two reactions, this portion on the end is identical. So that won't tell us which is the smaller amount of product. But what's left is the moles divided by the coefficient. Moles divided by the coefficient. So we do that. So for sulfuric acid, so moles divided by the coefficient from the balanced equation. And for sodium hydroxide, moles divided by the coefficient. And now, I like to call these reaction moles. Now the sodium hydroxide is a smaller value here. Sulfuric acid is larger. So the sodium hydroxide is our limiting reactant. So if we're just trying to answer the question of what is the limiting reactant, moles divided by coefficient, the smaller value of that will be our limiting reactant.